Okay, so in this lesson, we're going to be reviewing multiplying and dividing rational expressions. If you remember, rational means you have a fraction. So we're going to be multiplying fractions, dividing fractions. So if you remember when we did this before, to do this, the simplest way is to factor everything completely and then look to see if you have any common factors that you can cancel out, okay? All right, so this first example, we're going to start out with factoring every numerator and every denominator. So notice this first numerator is a trinomial, so sum is 12, product is 35. So that would be 7 and 5. So that would be x plus 7, x plus 5. And then looking at your denominator there, the sum is 3, product is negative 18. So that would be x plus 6 and x minus 3. Multiplies to negative 18, adds to positive 3. So looking at my second numerator, my sum is 4, product is negative 12. So that would be 6 and negative 2. And then your second denominator, sum is 3, product is negative 10. So that would be positive 5 and negative 2. Okay, so once we've factored everything completely, then you're looking to see if you have any common factors. Common factors are what cancels out that's on top and bottom or diagonal. So if you look, we have an x plus 5 and an x plus 5 here. We have an x plus 6 and an x plus 6. And then we have an x minus 2 and an x minus 2. And so notice on the top, we are left with x plus 7. And then on the bottom, we're left with x minus 3. Now, we've talked about this before. Remember, if you have more than one term, it has to look exactly the same to cancel it. So we cannot cancel those x's out because the top is x plus 7, the bottom is x minus 3. Those would be two different answers there. Okay, so this would be my final answer. Now, you also have to look at excluded values. So if you remember when we were talking about rational expressions, denominators cannot equal 0. So I'm going to go back and look at my denominators and see what would cause it to be 0. So notice this one, negative 6, would cause it to be 0, so x cannot be negative 6. This one would be positive 3. This one would be negative 5. And this one would be positive 2. So those are your excluded values, which means those are the values that you could not have for x, because if you plug it in, it would be undefined. Okay, let's try another one. So we are going to multiply. Notice this one, the second one is not a fraction, so we can put over 1. We're going to do the same thing and factor everything. So my first numerator, the sum is 7, product is 10. So that would be 5 and 2. And if you can't do these in your head, write down multiples of 10, go in order so you do not skip the one you need. My denominator here, I'm not going to be able to factor it, so I'm going to leave it as x minus 7. My numerator, sum is negative 1, product is negative 42. So that would be negative 7 and positive 6. Again, if you can't figure it out in your head, write down multiples of negative 42 and then find the one that adds to negative 1. Then I'm putting over 1 here. So looking at it, we're going to see if anything cancels. Remember, it has to be on top and bottom, has to look exactly the same or diagonally. So notice x minus 7 we can cancel out. So then we can't cancel anything else out, so we would have x plus 5, x plus 2, and x plus 6. There's nothing left in the denominator, so that would be my answer. But we have to also look at our denominators before we simplify, and x cannot equal 7 for that piece. There's not anything that would cause this to be 0 because it's just a 1. Okay, now we're going to look at dividing. It's very similar. We're going to be factoring everything. The difference is anytime we are dividing with fractions, we have to keep, change, flip. So factor everything, make sure you keep the first one the same, change your division to multiplication, and flip the second. Then you can see if you can simplify. So first step is to factor. So this first numerator sum is 10, product is 21. So that would be 7 and 3. My denominator sum is -9, product is 18. So that would be x minus 6 and x minus 3. Multiply, you get positive 18, add, you get -9. So anytime your product's positive, sum is negative, you're going to have two negative numbers. Okay, so I'm changing, the C stands for change. We're changing the division to multiplication, and then we are flipping our second fraction. So now on top, I'm going to have sum is -10, product is 24. So that would be -6 and -4. And then now this is our denominator. That's difference of two perfect squares. So that would be x plus 3, x minus 3. Okay, so then we're going to start looking for common factors. Notice x minus 6, I can cancel with x minus 6. There's an x plus 3 and an x plus 3. And that looks like it's it. So my top, I'm going to have an x plus 7 and an x minus 4. My denominator, notice I have two x minus 3, so you can either write it twice or you can just square it. Remember, you need to check for excluded values, which would make your denominator 0. So I need to look here. So x cannot equal 6 or 3. This one would be -3 and 3, but we already wrote -3 down. Anytime you're dividing, you have to also look at your original denominator at the beginning. So that's this piece here. So that would be 6 and 4. We already had a 6. So that's a common mistake, is forgetting about that original denominator before you flipped it. So that would be our answer there. Okay, last one. We're dividing, so we need to keep, change, flip. We did not do that on the first two problems because we were multiplying. You only keep, change, flip when you're dividing with fractions. So numerator sum is 1, product is -2. So that would be a +2 and a -1. Second, or the first denominator, sum is -4. Now, on all of these so far, the x squared has had a 1 in front. So make sure you don't forget to do 3 times 1. So product would be 3 there. So the denominator we would have, that would be x minus 3 and x minus 1. But we have to use a swing method. So divide both of them by a 3. And then reduce if possible. So the first one will become x minus 1 because we can reduce. The second one we cannot, so swing the 3 in front and that becomes 3x minus 1. So don't forget to use the swing method when that number in front of x squared is something other than 1. Okay, so we are changing our division to multiplication, and then we are flipping our second fraction. So now I'm going to have a 1 on top, which I can't factor. And then my new denominator sum is 7, product, notice that's a 1, so the product is just 10. So that would be 2 and 5. And then looking for common factors, we have an x minus 1. We have an x plus 2 we can cancel. So notice in the numerators, because when you multiply fractions, you multiply the tops. We just have a 1. We have to put something there. And then in the denominators, we have a 3x minus 1 and an x plus 5. So checking for your excluded values, 1 would cause that first one to be 0. If you can't determine what would cause this, then set it equal to 0 and solve for x. So 1/3. And then this one would be -2. This one would be -5. Looking at your original denominator, notice nothing would have caused that to be 0. So that would be all of our excluded values there. Okay, so this is a review of multiplying and dividing rational expressions. If you have any questions, please let me know.